Chapter 4 in the McEwen text covers precipitation. The following 3 video series will go over material related to precipitation. It should be noted that precipitation refers not just to rainfall, but also snow, sleet, etc. But for the purposes of this class, we will only discuss precipitation in terms of rainfall. The following learning objectives will be covered in this video series. First, rainfall has been displayed in numerous different ways. At times, it's based on actual measurements of a rainfall event that is occurring, while at other times it is based on a probability of occurrence. This first video will cover how to read and evaluate rainfall data from various sources. Then, we use rainfall gauge data for various different analyses. But at times, gauges will stop working, and thus it is essential to fill in missing data. The second video will cover how to fill in missing rainfall data for a given storm event. Third objective asks, how can we use the rainfall data to determine a rainfall estimate for a given watershed? Therefore, the third video will cover how to calculate the rainfall for a watershed based on gauges located within and surrounding the watershed. So let's talk about precipitation characteristics. Rainfall measurement is key in understanding how much rainfall has fallen at a specific time or for a specific storm. For example, on September 15, 2015, Los Angeles had received a record 2.39 inches of rainfall in 24 hours, making it the wettest September on record. As you note, the units used to measure the rainfall is in inches and sometimes millimeters. Rainfall is measured in the unit of depth is actually referred to as a volume. You might be wondering why. It's because rainfall falls over a watershed, which has a given area. Thus, if you take the rainfall and multiply it by the watershed area, it is a volume. Rainfall is measured at various gauges. The Fisher-Porter is an example of a rain gauge. One way the rainfall is measured is through a tipping bucket located within the rainfall gauge. I will bring one to class to show you how this works. There are other ways for a rain gauge to measure rainfall as well. Example is a scale that measures the mass. As rainfall is measured, at times the amount of rainfall can be classified as an extreme event, or at other times an average or a mean storm event. This is useful to know the difference because in design we need to know what type of event we are designing for. In an extreme event is used to design for conditions of high hazard. For example, a dam, while a mean rainfall event is used to design for more everyday projects, such as a storm drain or roadway gutter. The following are average rainfalls within Southern California. Do the numbers surprise you? It should be noted that Pomona receives more rainfall than coastal cities such as Long Beach. Why? This is because of orographic lifting, which occurs when an air mass is forced from a low elevation to a higher elevation. As the air cools, precipitation will occur. A rainfall hyetograph is used to display a rainfall distribution for a given storm. A hyetograph shows rainfall as a function of time. The hyetograph shows a distribution of the rainfall event. The y-axis is rainfall depth, while the x-axis is time. Many times a hyetograph is shown as a rainfall intensity as a function of time, so it is important to be able to convert rainfall depth into rainfall intensity. All that is required is to take the total depth of rainfall for the given time period and divide it by the change in time. Note that rainfall is not constant, and it changes both with time and location. Next, we're going to discuss what a volume duration frequency graph is, or a VDF. This following figure is a VDF. Please pause your video and go to your note packet and find the volume, duration, frequency graph for Orange County. Volume is the amount of rainfall measured in depth in terms of depth that has fallen. It is assumed to be uniform within a watershed for a given duration. Duration is the length of time over which the storm event occurs. Note that if the rainfall is constant over the entire watershed for a long period of time, the peak discharge will occur at the travel time of the watershed. This is why travel time, time of concentration, and duration are interchangeable. We will further discuss this in class during our next meeting. Frequency or return period is the length of time between storms of the same volume and duration. The return period can be determined as 1 divided by the exceedance probability. The exceedance probability is the probability of having a specific storm volume and duration in a given time period, usually 1 year. Thus, a storm that is defined as a 100-year storm has a 1% probability of occurrence in a given year. So can it happen again? Yes. Just because we have had 100-year storm in year X does not mean that we cannot have another 100-year storm. In addition, we could have a 100-year storm in year X and have another 100-year storm in the subsequent years. What is an intensity, duration, frequency graph, or an IDF? The following figure is an example of an IDF. Please pause the video and find your IDF graph for Orange County in your note packet. The main difference between an IDF graph and a VDF graph is the y-axis. An IDF graph is an intensity graph, while a VDF graph is a volume graph. Intensity is determined by taking the volume and dividing it by the duration. Thus, intensity is the rate of rainfall in inches per hour. Review the 2 VDFs and 2 IDFs for Orange County provided in your note packets. Can you see the differences and similarities? Be prepared to discuss during our next class session. An Isohyetal map is another way to display rainfall. The following figure can be found in your note packet. It is the Isohyetal map of San Dimas. It is for a 50-year, 24-hour storm event. Please pause the video and find the graph. The highlighted blue lines represent the rainfall isohyets. I have circled the rainfall depths in red. Thus, if you want to determine the 50-year 24-hour rainfall for a specific location on the map, all you need to do is interpolate. The isohyets are similar to elevations on a contour map. Please move on to the next video.